Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Whispering Caves by Yitrio. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. Shade some cells such that all shaded cells are connected orthogonally by other shaded cells to the edge of the grid. And the remaining unshaded cells form one orthogonally connected area. So an example of this would be like, for example, you could have this being shaded and this being shaded. And the unshaded part has to form some sort of orthogonally connected. There has to be only one orthogonally connected area. And orthogonally just means that the cells share an edge. So this would be orthogonally connected because all the shaded regions are connected orthogonally to the edge of the grid. And this is orthogonally connected right now because all the unshaded cells form one orthogonally connected area. Now, this would not work because basically we would have to have two orthogonally connected areas, right? Because this is only connected diagonally and not connected orthogonally. So that's the rule set for the shading. Okay. Digits in circles cannot be shaded and represent the total number of unshaded cells seen horizontally and vertically from that cell, including itself. So if we did the previous one, well, first of all, this wouldn't be correct because we have the circles in the shaded areas. But digits in circles, so the digits in the circle represent the total number of unshaded cells seen horizontally and vertically from that cell. So this would actually be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this would have to be 11 if it were actually correct, but it's not, right? This would be 1, 2, 3, 4, 5, 6, 7, because it only sees 7 horizontally and vertically because shaded cells block vision. So it cannot see these, and it cannot see that one. This would be 4, so this would be 7 if this were to fulfill what the digit in a circle means, and this would be 4, right? Because it sees 4 unshaded cells. And remember, it's the unshaded cells that the circles see. And vision is blocked by shaded cells. If two orthogonally connected cells are both unshaded, then the digits in those cells must have a difference of at least 5. Okay, so basically, if two orthogonally connected cells are both unshaded, then the digits in those cells must have a difference of at least 5. So this is the German whisper rule. So anytime you have unshaded cells together, it must contain, so say this was a 3. This would have to be an 8 or a 9 to be next to it. Because, again, orthogonally adjacent cells, orthogonally connected cells are both unshaded, then the digits must have a difference of at least 5, which is the German whisper rule. Okay, so that's for unshaded cells. If any unshaded cells are orthogonally connected, then the digits must have a difference of 5. And so therefore there's nothing about these two, for example. Though there is, so if this were 3, we'll get into that once we start solving it. Digits in cells separated by a white dot must have consecutive values. Additionally, one of those cells must be shaded and the other must be unshaded. So we know that for any two cells that are separated by the white dot, which are called white Kropke dots, one of them is shaded and one of them is unshaded, right? So therefore, yeah, and we're going to make shaded here blue and unshaded green. That we know have to be, right? Additionally, and they must have consecutive values. So for example, if this were a 7, this would have to be a 6 or an 8 to maintain the consecutiveness of it. And those are all the rules. If you'd like to play along, there's going to be a link in the description. I'm armed with my brain juice, so we should be ready to go. And I'm going to get started. Let's go. Okay, so one thing we know then is that all of... whoops, we don't want that. We want edge only. All of these white dots mean a boundary between shaded and unshaded. In addition, all the... what is it? All the digits and circles cannot be shaded, right? So therefore, they're all green. They're not... so therefore, this C is the same as this one, right? So obviously, it can't be the full 9. We know these are at least 2. Oh, interesting. We know one is shaded. Actually, both of those are unshaded, right? And they're both orthogonally connected. So, for German Whisper, we know that every time you go from one to the next cell, from one cell to an adjacent cell, it'll always switch between going from low to high. Actually, so then we need to probably actually change. We're going to probably have to switch some of what we want to do. So there's actually 3 sort of things that we want to take care of. We probably want high and low. And we also want... yeah, we want high and low, and we also want the ability to... yeah, we also want the, obviously, the shaded areas. So we're going to make the change now. Instead of being blue as shaded, we're going to have pink as the shaded. And we're going to have red as high and blue as low for the unshaded. Because on a for a German Whisper rule, anything that are 2 adjacent cells that follow the German Whisper rule must be of different sets. One has to be 1 through 4, and the next one has to be 6 through 9. Because obviously, the 1 is the minimum that you can have, and if you have the minimum distance away from there, that has to be 6, right? So anytime you have a digit from 1 through 4, it must be a digit next to a digit from 6 through 9. And vice versa. So it always alternates between high and low. We also know that all unshaded cells are in one orthogonally connected area. So these all have to be orthogonally connected to each other somehow. Now the thing is, the low here cannot be 1, right? Because they both see each other. So therefore, the low at minimum has to be 2. If this were high, say this was high, right? If this is high, I don't even know if this can be high. So say this was high, right? It obviously could be 6. 1, 2, 3, 4, 5, 6. But then there would be 7 specifically. It could be 6. But if it's 6, the problem is for this to be low wouldn't work, right? So it can't be 6 because there can't be a 1 here. So say this was 7. Well, if this is 7, the problem is only 3 of the 7 can go this way because we know we're blocked this way, right? At least. So if this were 7 as the high, The problem is this would see 4, definitely, right? So this can never be high because it's the same problem. It would just continue on. If this would have to be 8, it would have to have 5 in this direction, which would mean this would have to be 5. So this can never be the high. Therefore, this has to be the low, which means this has to be high because they're both unshaded and they're orthogonally connected. Now the thing is, you know all the unshaded cells are orthogonally connected. Therefore, they must be high or low. You cannot have a 5 cannot be in the unshaded cell, right? Because you know all unshaded cells are orthogonally connected. And anytime you have two orthogonally connected cells that are both unshaded, the digits must have a difference of at least 5. But 5 can never be 5 away from any other digit, right? It can be 5 away from 0, but that's not in normal Sudoku. And it could be from 10, but obviously that's not a digit. So therefore, this has to be shaded. Any 5s have to be shaded because you can't, all the unshaded cells are orthogonally connected and all the shaded cells, all the unshaded cells are orthogonally connected in one region, so it has to have obviously something next to it. So therefore, anytime you have a 5, you cannot have it be shaded. It has to be, can't have it be unshaded. It has to be shaded. Therefore, this is shaded, this is unshaded. Also, okay, since we're alternating between highs and lows wherever we go for the orthogonally connected cell, I've spoken about this before in some puzzles, but basically, anytime you have an alternating set, you always know that if you have something that's also part of the set, it always alternates to the same set, right? So if, like, obviously this is blue, red, this would have to be blue and red, then this would be blue if say all of these were part of the region. But whichever way you get to here, however you get here, it has to basically follow the same, it has to be in part of the same set. So for example, if we just went this way instead to connect to here, this would be blue, red, blue, red, blue, red. So the blue, red, blue, red, blue, red, blue, red, blue, obviously. So that would be blue. And then this would be blue, red, blue. So any way that you get to this cell, and you do have to get to that cell because all of the unshaded regions are orthogonally connected. Any way you get to that, this would have to be blue. So this would be low. This would be low too because obviously blue, red, blue. This would be red, blue, red. So therefore this is high. This would be red, blue, red. So this would be high. To get to here, this would be blue, red, blue, red, blue, red, and blue. So this is blue too. That's low. To get to here, this is red, blue, red, blue, red, blue, red, blue. So this is also blue. Therefore, we know these have to be 1 through 4. And this has to be 6 through, well, okay, this can't be 1 through 4. This has to be at least 2 because it sees 2 here. And this has to be at least then 7, 8, or 9 because it has to be 5 away from this one. So the thing is, if this is 2, this would need to see 5 other ones, right? At least. And it has to see the total number of unshaded cells, right? Because if this is 2, that means all of these are shaded. So therefore, this can't extend anymore this way. So this would see 2. This would have to see 5 more. And there would have to be all this way. Same thing if this is 3. If this is 3, this has to be 8 then, which would have to see at least 5 more this way. So therefore, what we know then is that this has to go blue, red, blue, red, and blue at least. It has to see at least this. It could be two more, but we don't know, right? This blue is next to two unique digits on a German whisper, a German rule set. So it has to be at least, it cannot be 4, because 4 can only be next to one unique number on a German whisper rule set. So this is 1, 2, or 3. Same here. This has to be next to 1, 2, or 3, because it has to be next to at least 2 unique digits on the German whisper line. This sees 2 at least. If it connects here, it would see 4. But then this would see 4 at least, and it would have to be a low. So this cannot connect this way. Because again, if it connected this way, this would see 4. This would have to see more than 4 because it sees at least 4, but it can't be the same as this one. So therefore, it can't see. Therefore, this one is shaded. So it's not shaded. Sorry, it's not unshaded, if that makes sense. So this could see 1, 2, this could see 2, 3, or 4. What about this one? Oh, none of the circles that are low can be 1, right? You always have to be orthogonally connected to something, to the unshaded region. Therefore, it's always 2, 3, or 4 at least. Right? These can be whatever, right? So it's 7, 8, or 6, 7, 8, or 9. This is next to 2 unique numbers. So it must be 7, 8, or 9. This is next to 2 unique numbers. So it's also 7, 8, or 9. So this could be 1, 2, 3, 4. These could be 1 through 5 and 6. So 5 and 6 both have to be here somewhere. If this is 6 here, so say this is, okay, say this was 5. If this was 5, this would have to contain a 6, but then 6 would be consecutive with 5 only. So this can never be 5. So therefore, the 5 always has to be one of these two. Oh, that's interesting. And one of them shaded and one of those unshaded. So therefore, we know, okay, so therefore we know if this were 5, this would have to be 6 and shaded because 5 can never be shaded. But the problem with that is if this is 6 and shaded, it's a high, which means it would have to alternate back to here, but then this would be high, low, and this would have to be high. And that set would always be the same again. So this can never be 6 then. This has to be 5. Okay, wait, actually, it could be 4 though here. So if this is 5, this could be 4. Okay. So 5 has to be one of these two again. If this is 5, this has to be 4 to maintain essentially the German whisper quality. Because it always goes blue, it would always alternate blue, red, blue. And so in a checkerboard pattern, you could be blue here. And these would be blue, right? But if this is 5, okay. Say this was 5. If this is 5, this has to be the 6, right? Because this cannot be 5. if you go alternate on this, this would be low, high, low, and then high, right? So this cannot be 4. So therefore, this would be 6 if that were high, and it would have to be unshaded. So therefore, it would say, well, actually, we don't have to, never mind. So this could be 5, and this is 6 unshaded. Sorry, yes, 6 unshaded. Or this could be 5, and this would be 4 unshaded. And this could be either 6 or 1, 2, or 3. I guess it could be 4 also, yeah. Right, this doesn't have a circle around it, so we don't care about anything else there. Okay. This cannot go all the way here. If it goes all the way here, that would make this C 6, because you would see all these, but then this would have to be 6. So this cannot go all the way here, which means this is at most 1, 2, 3, 4 that it sees. It would have to see, therefore, these two at least. So therefore, this is blue, and this is red. So this is at least 2, right? Obviously. This sees 2 unique numbers, so it has to be 1, 2, or 3. This must see at least, it could go 6 this way. Or it could go here. So we don't know which way it has to go here. Oh. If it does that, so it has to see at least 6. And we know it can't go all 6 this way. So it has to go here, and it has to go one of these two spaces. Well, the thing is, if it does that, it will see this can't be 6 then anymore, because it would be next to 2 unique numbers. So this can never be 6 then. It's always next to 7. So therefore, you always have at least these 6, right? So we know this is a unshaded space, and it has to be low. This is 2 unique numbers, so this must be 7, 8, or 9 also. So it could be 7 this way. Or it could, actually, no, it can't be 7 this way. Say it was 7 this way specifically. The problem is this would be next to 3 unique numbers, and therefore it couldn't be 7. So if it's 7, it has to go this way. And so therefore this one has to be a unshaded cell, and it sees that, right? If this is 8, it would have to see all 5 of all of these. Again, it cannot go all the way here, right? Because if it does go all the way here, then this would see 6 digits, or 6 unshaded cells. So therefore, this would be 6, but that's not possible. Therefore, this is shaded. This has to be at least this one and this one. This, so therefore, that's low and high. This must be unshaded because of the nature of the white crop key dots, which separate cells, which must be one must be shaded and one must be unshaded. So this is unshaded, therefore this is shaded. Therefore this is 7 or 8. It cannot be 9. If it's 8, obviously it would be next to this, and then this would be 4. Ah. I guess it could go that way. That's possible. Okay, let's see then. So this is unshaded. Okay, so let's divide into what we know are shaded and unshaded. Let's make it red because it's, well, actually, let's make it green. so that we can differentiate between the box borders and the actual divisions. It's a little hard to see there, but anyways. So this has to be shaded then. This could go here, and then this would be 4. Okay, so if it went this way, this would be next to 2 unique numbers and would have to be 4, which is not possible. So this has to be shaded. So therefore, these cannot be in a region. So it could go 4 this way and then this. That's fine. Or it could be 2. So this is next to 2 unique numbers, so it's 1, 2, or 3. This could be next to 1 unique number. So this is 7 right now. It could be 8. If this is 7, this has to be 1 and 2. So that's fine. If this is 8, this would be next to 1, 2, and 3, and therefore this would be 4. Which would have to be next to 9 and 9. That seems okay. This can't be 4. Oh, wait, it could be 4. It could go this way. Well, no. If it's 4, this has to be next to 9 then. If this is 4, this has to be next to 9, which would force it to go this way. Right? Because there's no other place to get 9 here. Oh, actually, I guess it could go down here. Never mind. So it could go 4 this way. That would be 1, 2, 3. Can it ever go this way is the question. I guess it could be 3. That could be the possibility. It could go 3 and then that way. So this could be 6 through 9. This is 1 through... This cannot be... This is between 2 unique digits in a German whisper rule. So it could be 1, 2, or 3. This is 6, 7, 8, or 9. So this has to be 5, 6, 7, 8, 9 to be consecutive with it. This could see 2 this way. So it could be 4 this way. Then this could be 9 by going down. But if it did that, so it cannot go 4 this way, right? Because then this would have to be between 2 unique digits, and therefore can it be 4. So if you go 4 this way, so you can't go 4 this way. You could potentially go here, right? So it could be 4 down here, and this would be 9 and 9. But if you did that, this has to be 9. So we'd see 1, 2, 3, 4, 5, 6, 7, 8, 9. But the problem is then this would have to be 4, and this would have to be 5, so therefore this would have to be 6. But 4 and 6 are not 5 separated by, don't have a difference of at least 5. So that does not work. So this can never be 4 then. This is 2 or 3. So it could just be these two, in which case these are shaded. Or it's 3. So can this ever be 9 then? It can't go the full 8 this way. But it could go 9 here. In which case this would be 6, 1... 6, 1. This would be 4 and 5. Oh. That doesn't work, right? So say it went 6 all the way down here. The 5 obviously could not be part, it has to be shaded. The 4 would have to be unshaded then. And therefore, but it would be next to a 6. But that's not possible then, because you would have two unshaded cells which which don't follow the German whisper rule. So this can't be 6 then. We know then this is 6 and this is 5. And this has to be unshaded, so this is because the 5 has to be shaded. These two then cannot actually fit the German whisper rule, because 1 through 4 can never be next to 1 through 4 on a German whisper rules in between. Therefore, this is unshaded. Sorry, this is shaded. So we know then this ends here, right? So this is 1, 2, 3, 4, 5, 6, and 7 at least. And it could be 8, but it can't be 9. So this is 7 or 8. So if this becomes 3, so say it became 3 this way, the problem is this would have to be 8, and this would see 1, 2, 3, 4, 5, 6, and 7, but this one could not be unshaded because the unshaded one would be here. Therefore, if we try to make this unshaded, it doesn't work. So therefore, this always has to be shaded, right? So if this is unshaded, that would mean this has to be 3. This has to be shaded, but then this would have to be 7 because it sees only 7 unshaded cells because this has to be shaded. But then you would have 3 and 7 next to each other, which would be not possible. So this can't be 7 or 8 because we have a 7-8 pair in row 1 because this is 7 or 8. This can't be unshaded because we know, we tried making it unshaded, and that makes this 3, but then this would be forced to be 7 to maintain that. Therefore, this is shaded here, and therefore this is a boundary. What else do we know? We have a 7-8, 7-8 pair. So if this is 3, this would have to be between 9 and 8. That works then, because that would be 9, 8. This would be 7. This would be 1 or 2 with 6. So this would have to be 1. So this can never be 2 then. If this is 2, obviously, if this is 3, it has to be extending this way, and it would have to be between 8 and 9, which would force this to be 6, which would make that 1. If this is 2, obviously this couldn't be 2. So this can never be 2 here. Okay, so if this is 6, it cannot be all 6 here, because then it would see 2 numbers on the German whisper line, on rules, with the German whisper rule set, which is not allowed. But it could be something like that. That seems plausible. This, okay, we don't know if it sees 6 or it doesn't. There's nothing, it's not a circle, so you don't have to worry about that. The 9 has to be one of these two. So we don't know what that is. Hmm. So this one we're not really sure of, right? If it's 4, it has to be 4 that way, which is possible. If this is 4, it could go down, and this would be 9 and 9. That's possible too. This could be 8 and goes that way. If this is 8, this is 7, so this would have to be 2. This would have to be 3 then. And therefore... Wait, no, this could be 1 or 3. That's fine. Then this would be 1 or 3, if that's the case. But we don't know if it is. If this is 7, this has to be 8, 3, and 9, which makes this 6 and 1. If this is 8, this is 7 and 2. Hmm. Huh. Hmm. Okay. This can't be 5. So 5 is one of these two, or it's this one. 5 has to be one of these two. We also know there's a 5 either here or here. So if this is 8, this is 3 and 9, which makes this 6, 1, 7. And that seems fine. Oh, one thing is this can never be 8 and 9, right? Because if this is 8 and 9, that would force both of these cells to contain a 7, which is obviously not allowed. So this cannot be 9. If this is 7, 8, obviously can't that doesn't work because that eliminates all possibilities here, so this can't be 8 either. If this is 6, 7, it could be 6, 7. So one of these is 6. We know that for certain. Therefore this can't be 3 actually, because if this were 3, this would have to be next to an 8 at least. So therefore this can't be 3. This could be, so we know one of the 6s here. It's either 5, 6, or it's 6 and 7. Um, hmm. This can't be 5, so 5 has to be one of these 3 cells in column 8. Hmm. Um, hmm. So let's try this again. If this was 8, this would have to be 3, which makes that a 9, which makes this 6. Therefore, that would be 7. This would have to be 1. This would then be 2, which makes that 1, which makes that 6. So far this works. That's 5. This would be 3 or 4. Two could not be either, could not be there. So it's 2, 4, 5, 2, 4, 5, 2, 4, 5. This all works. So this would be 1, 2, 3. Yeah. What if we try the other way? Say this was 7 and this was 8. This would have to be 2, obviously. This would be 1 or 2. This would have to extend here. So this would be 1 or 3. And therefore this would be 2. So either way, I think this has to be 2 then here. Right? We just tried it with 8. So if we have... Okay, let's remove the 5. So say this was 8. If this was 8, this has to be 3 because it must extend in CVs. Therefore, this has to be 3, which forces this to be 1, this to be 7. Obviously, this extends this way, so 3 can only be next to 8 and 9, so therefore this must be 9. Therefore, this must be 6. If this is 7, it can only be next to 1 and 2. This can't be 1 anymore, therefore it has to be 2. So this one's always 2 in that case. Now, if we try to make this 7, this has to be 2. This has to be 8. This doesn't connect anymore here. This cannot be 3. This sees 8, so it must be next to another low. So this would be 1 and 3, and this would have to be 1 or 3, because it cannot be 2 because of this 2, and it can't be 4 because 4 can't be next to 8. Therefore, this would be 1 and 3. We would have a 1, 3, 1, 3 pair in box 3, which means the rest of the box cannot contain 1 or 3, which would force this to be 2. So either way, this has to be 2 no matter what. Row 2, column 8 has to always be 2 no matter what. So therefore, this is 2, which forces this to be 1. So this can't be 2. This can't be 2. This can't be 1 now. Okay. That works, I guess. Therefore, the rest of the column cannot have 1, 2, or 6. It has to have 3 or... Okay. Where are 3 or 4 in column 8? Can't be any of these. It must be one of these. So both 3 and 4 have to be here, which means this can't be 3 or 4, because in box 9, the 3 or 4 has to be in column 8. So therefore, this can't be 3 or 4. This has to be 2, which means it goes one way and then it extends another way. Right, so it either goes this way and then goes here in, or it goes this way and goes in. So therefore, this must be one of the unshaded cells, because all the unshaded cells are orthogonally, is in one, I can't speak, is in one orthogonally connected region. Therefore, this must be a low, but one of these two is high when we're not sure which. So this must be a low, which means it's 3 or 4. And it has to be connected to 2 unique digits. Therefore, this must be a 3. This can't be 3 then. And it must have an 8 and a 9 with it. So either that's 8 or 9, or this is 8 or 9. It cannot be 8 and 9, 8 and 9. But it could be something like here than 8 and 9. That's possible. We're not sure. So this is 2, and then extends, and then goes, yeah. So 4 is one of these two. And then it could also have, what, 5, 7, 8, or 9. Yeah. 2 cannot be here, therefore 2 has to be one of these 3. This is 3 or 4. Obviously, if it's 4, it has to go down then. So if this was 4, it would have to go down, and therefore this would be 9 and 9. That's possible. You would need to extend one more here or one more here. If it's 3, it could just go down here. Oh. Well, but it could go here too. One thing we know is this can't go 6 all the way down here. Right? Because if it goes 6 all the way down here, it has to extend here. And extend here. So if it's 6, it has to specifically... Actually, can it ever be 6? Is the... Well, I guess it could be if this is 4, right? And then 6 that way. Oh. 6 can no longer go here, right? But it doesn't have to be 6. Right? This could be 7 or more. If it is 6, obviously it cannot go all the way here, because then this would have to be 1 and 1, and 6 can't be next to 2 1s with the Sudoku working. If we tried to go 6 this way, obviously that doesn't work, because this can't be 1, so therefore this can't be 6. So I don't think this can ever be 6, right? Because if it's 6 going this... I guess it goes 6 that way. That is possible. So it could go 6 this way. So it still could be 6, actually, then. Huh. So we know none of the corners can contain 8 or 9, right? Because it must go here, then here, then here, or here, then here, then here, or here, then here, then here, or here. It cannot go this way, though. So it's either this, or it's this way, right? Because if it went this way, one of these would be 8 or 9, but then we have a 7, 8, and 9 triplet there. So the 8 and 9s have to be in the corners. Therefore, you can, or in the next to the 3 somehow. So the corners have to be, could be 1, 4, 6, and 7. And those are the only possibility. I guess it could be 5. 5, 6, and 7. 1, 4, 5, 6, 7. Hmm. This has to be shaded because if it's not, it's connected on three sides. It would, if it's not, if this is not shaded, it would block this in, and we know all the shaded cells have to be connected orthogonally to the edge of the grid by other shaded cells. Therefore, this is shaded. We don't know about this. This could actually connect somewhere this way, so that's possible. So this is unshaded also. Sorry, this is shaded. Therefore, we know this one's blocked off. So it still could be 6. Hmm. That's not helpful. Okay. Hmm. So say this was 6 and 7. If this was 6 and 7, this would obviously have to be 8. This would be 7, which would force this to be 2, this to be 1. This would be 1 or 3, which would force this to be 4 and this to be 9. So therefore, this would be 9 then, because it would have to go this way. This obviously could not be 4. This could not be 9 or 7. Therefore, this would be 8, which would force this to be 9. Neither of these can be 1. Again, this was 6 or 7. Therefore, this would have to be 4 or 5. This would be 4 or 5. So, okay, again, we would have to force, it would force that. It would have to force this way then to connect. So this would be 8 and 9, 8 and 9. So the 4 or 5 could not be in the corners. This would be 1, 6, 7, 1, 6, 7, 1, 6, 7. Either this one is or this one is unshaded, but we're not sure which. Oh, this can't be shaded because we would have 1, 3, 1, 3, and this would be have to be unshaded. So therefore, this would have to be unshaded, which would mean this is shaded. So this would also have to be shaded, right? Because then you would have, so therefore this would be 2 or 3. This would be 6, 7, or 8. And it would be next to an unshaded cell, which would be 5, 6, or 7. This would be 5, 6, 7. So far this is looking okay. This can't be 5, therefore the 5 would have to be one of these. You have also 6 and 9 with 4. With 4, excuse me. 6, 9 with 4. So all of this is looking fine. This could not be 9. This could no longer be 6, because if it were 6, the problem is would be next to a 2 or 3. So this can't be 6. This would have to be 7 or 8. Which could go this way. This one we don't know. It could connect this way. It cannot connect, obviously, to either of these. It can't connect to here because this is only 2. So this is either 2 or 3. Ah, this couldn't be 5. Therefore, this would have to be 8. Well, again, because this was a 6, 7, 6, 7 pair. So this would be 8. This would then have to be 7. So this would be 6, 5, 6, 5, which means this couldn't be 5, which would force this to be 5. This couldn't be 8, so this would be 9. This would be 8. So that's looking fine right now. This can't be 7 then in that case. This can't be 1. It would have to have a 4. So this is all looking fine. This couldn't be 3 because this would be 6, 7, 6, 7. Therefore, this would have to be 2, which would make this 7 and this 6. Which would make this 8. So far, this is all looking kosher. I guess it could connect that way. No, it cannot connect this way. So if it goes that way, it cannot connect that way because then this would have to be at minimum 3, and that can't be next to 7. So it has to connect this way then. So this is at least 5 here. Therefore, this can't be 2. It could be 1 or 3, which is fine. This is all looking kosher then. So if this is 6, 7, the 7 has to be here. That's all we've shown. So if this is 6, 7, this cannot be 7. This would have to be the 6, and this would be the 7. Obviously, still could be 5, 6. So, okay, what happens if it's 5, 6? If this is 5, 6, that means neither of these two can be on the none of them can be shaded or unshaded, sorry. It's because they would have to be both 1, and we already have a 1 here. So these would both be shaded. Oh, that actually is a good question. What happens if this is... So if we ever have this be shaded, that means this is if this is unshaded, that means it has to be... We would have 4 unshaded here. One of these would have to be 4. Therefore, this would always be 9, if that's the case. And this would be 1, 3, or 4. This could not be shaded anymore, so therefore this would have to be 7. Therefore, this would be 3, 4, 3, 4. This would have to be 1, which would force this to be 2. Which means this couldn't be 9. So therefore, this is a 9. It would not... This would be shaded. This would be shaded because this would only see 2. It's looking fine also. This would be shaded also. And it would be consecutive. So this would be 3 or 4. This could not be 5, so this would also be 3 or 4. So this could not be 3 or 4. Therefore, we'd have what, 5, 6, and 8. This would be 5, 6, and 8. This can't be 8, 7, so therefore this is 8, which would force this to be 7, which forces that to be 2, and that 1. So this can't be 1 or 2. This can't be 1 or 2. Therefore, this can't be 8. This would be C8 total, so this would have to be 3, which would force this to be 9, which makes that 6, which makes that 5. Which makes this a 6-8 pair. So this becomes 2 or 4, but it can't be 2, so therefore this is 4. This would have to be 2. This could not be 2. So far this is looking fine. The 5 would have to be one of these two. Then we have 3 and 9, and obviously 9 could not be here. This couldn't be 3, therefore this would be 5. Huh. So this would be a 3-9 pair. So therefore this would be 6. This would be 5. Therefore these would be shaded because you can't have unshaded cells next to the 6 because we already have the 1 here. So this could not be 6. So that's looking fine also. This would have to be not 5, not 7, not 9. So it's 4 and 8. 4 and 8, 4 and 8, which means this can't be 4. This can't be 4. So 9 is one of these two. We're not sure which. This would not be connected. But then this would have to connect this way. Right? So then this would be 4, and this would be 3, and this would be 4. So this would be 9. Okay. So, yeah. Either way. So again, we tried... We tried connecting... we tried not having this be a connection. So assume this... So we tried assuming... So if this is not unshaded, that means this must see 3, and therefore it must see at least this. So this has to be unshaded. We tried then, if it goes this way, that led to essentially this being 6. So these could not be shaded. Sorry, these would be shaded and not unshaded. And therefore, the only way to connect would have to be through here, which would mean that this is shaded or unshaded. So either way, this is unshaded, so it cannot be 2. This has to be 8 or 9. So again, we tried going both ways. So without this, this goes unshaded, and it could be 3, so this could be 8 or 9. So this can't be 7 anymore, because if this is 7, this would have to be this. It can't be next to a 3 or 4. So this can't be 7, therefore it's at least 8 or 9. So it could not be 3 going this way, as we showed. And the specific reason would be because that has to be 7 then. Because it can't see this one. Because it would see 1, 2, 3, 4, 5, 6, 7. Yeah. So if it went here, this would have to be 7 because it couldn't be here because that couldn't be a low. There, because we'd have 4 lows already in box 3. Therefore, this would be 7, which would force this to be 6, which means both of these are shaded. Because you can't have unshaded ones that would be next to the 6, because we already have a 1 in that box. Therefore, since these are shaded, to orthogonally connect this with the rest of the unshaded cells, it has to go here, then here. Okay, so there's that. Where does it connect this way? Can it connect this way? Oh, that's interesting. Okay. Huh. So say again, this was the last, say this was unshaded. If this is unshaded, therefore this is shaded. That makes this 1, 2, 3, and 4. So there cannot be a 1, 2, 3, 4 here, which means this has to be shaded because it can't be next to the 7 or 8. So therefore, this would have to be 7 because it sees 1, 2, 3, 4, 5, 6, 7. So therefore, this would be 7. This would be 6. This would be 5. This would be 8, which means this would see 1, 2, 3, 4, 5, 6, 7. It would have to see that one. Therefore, that's unshaded. Therefore, this is 3. It sees 9. This is 6. This is 1. This becomes 3 or 4. It cannot be 5 here, so this must be 3 or 4 with it. This is 6 again, and therefore these have to be unshaded. Sorry, these have to be shaded, therefore the unshaded part has to go through here. But this can no longer be 6. And somehow this must connect. I guess it could connect this way. Okay. So say it connected this way through somehow. The problem is it also needs to connect to here too. And when it does connect there, it essentially will block off this section of shaded cells from the edge. Right? Because if so say this was essentially connected to here, because otherwise, obviously it can't go this way. Actually, that doesn't work either. This is now 7, 8, or 9. It has to connect this way then. Right? Because otherwise it won't have enough to get 7, 8, or 9. Right? There's only 6 cells here. So it has to connect this way because it can't connect this way. Therefore, this shaded cell is not connected to the edge of the grid. Therefore, it cannot be this way. Therefore, we know in this convoluted way, this cannot be unshaded. So this has to be shaded, which makes this unshaded. So this is 6, 7, 8. This is shaded. This could be 3 or 4. This still could be 7, actually. Actually, I don't think so. So again, if this is 7, this becomes 6 and 5. Which means these have to be shaded, which means, again, it connects this way, and then you have the same problem again, right? Because this cannot be 6 anymore. Therefore, it can't get it sees only 6 this way, so it would have to connect this way, but that would block this shaded cell from ever touching the edge orthogonally from shaded cells. So this can never be 7, because if that's 7, then this becomes 6, and therefore this is 8, which makes this 7. This has to be 2. These can't be 7. This can't be 8, so therefore this is 9. Again, this can't be 6 because that was the whole point of that failed there. Therefore, this is 7. This is 6. This can't be 7, 8, or 9. This can't be 7, 8, or 9. So this is 4, 5, 4, 5. Therefore, both of these have to be shaded, which means these are the unshaded cells, right? So this is 8, 9, and 8, 9. This can no longer be 4, 5. This can't be 4, 5. This can't be 4, 5. Therefore, this is 7. This can't be 7. If we tried... So I think going this way to connect... Well, okay, it could connect that way. No, it cannot connect that way. We know for certain this can't be connected because it specifically only sees 2. So this cannot be unshaded. This has to be shaded. So it cannot connect this way. So this always has to connect either here or here, right? And we've shown that if it connects here, if it connects this way, you can't have all 6 of them go down because then this would have to be 1 and 1 surrounding a 6. And it wouldn't connect. So you have to connect somehow to here. And if you tried to go this way, I don't even know how. Yeah, you can't get 6 going down that way. You always have to connect that way if that's the case. So it would connect here. It would block this always. So this would always be not orthogonally connected through shaded cells to the edge. So it cannot go this way. Therefore, this has to be unshaded. It must connect here. So this must connect this way, which means this has to be a 2 to be connected to the 7, or to be adjacent to the 7, and still fulfill the German whisper rules. This can't be 7, so this is 6 or 8. It has to be next to 5, 7, or 9, but there's no 9 here, so this is 5 or 7. These are now, this sees 4 digits, so therefore this must be a 4, which makes this a 9. Therefore, we have the boundaries here, too. And we have the boundary here, and we have the boundary here. So this has to be shaded here. This sees 8. So therefore, it sees 1, 2, 3, 4, 5, 6, 7. And therefore, this is 8. So therefore, this is a low, which makes this 1 or 3. This is now... boundary because it only sees 2. Therefore, this can't be... This is shaded. This sees at least 3. It can't be 6, though, because it's next to a 2. So therefore, we have an 8, 9, 8, 9 pair. This can never be just... Well, I guess it could be 8 that way. But the thing is, it needs to connect somehow to here. I guess it could connect here, this way. This, again, is 5, 6, or 7. This is 5, 6, or 7. So the 6 has to be one of these two. This is 4, 5. This is 4, 5. This can't be 6. Therefore, this is 8, which makes that 7. So this can't be 7. This can't be 7. We have a 5, 6, 5, 6 pair in row 2. So this can never be 5. So therefore, this must be a 5. This can't be 4. This can't be 9, so this must be 8. Which means this could be next to 2 or 3. This is 8, therefore this is 9. This has to be 8. This cannot extend that way, because if it extends this way, this would have to be a 3, because we already have 1 and 2 there. But the 3 cannot be next to a 7. Therefore, this cannot be unshaded, so this must be shaded. This cannot be unshaded because it has to orthogonally connect to the rest of the unshaded cells, so therefore this is shaded. So we now know this is a border. This 5 or 6 cannot be 5 away from 2, so therefore this is also shaded. So we know that now. Let's see. So this can see at most 7 with these cells. Therefore, it must connect to here. Therefore, this is a low. It sees at least 5 here. It could see all 8 this way. So how does this touch the edge orthogonally? This must be shaded so that we have a now connection. This can't be 5 or 6. It can't be 7, 8. Can't be 2. So it could be 1, 3, 4. No 5, 6, 7, 8. Or it could be 9. And this can't be 2. This can't be 2. This can't be 2. Where's a 2 in box 2? It has to be here. So this is a 2. So therefore it sees only 2 cells, which means this can't be unshaded. So this is shaded. This has to be 1 or 3 because it's next to 2 unique cells. Let's see. This has to be what? 3, 4, 3 or 5, and this is 3, 4 or 5. This can't be 7 anymore. This connects this way. This has to connect somehow to here or here. This is what? 1, 3, 4, 5, 6. This would be 1, 3, 4, 6, 9. Okay, can't be 1 or 3. This is 4, 6, or 9. One of these has to be 5. So this is 4, 5, 6, and 9. This has to be, what's left over? 1, 3, and 6. So 6 cannot be here because we have a 1, 3, 6 triplet in box 1. Therefore, this has to be 7. It cannot have a 5. Cannot be 1, 3, 2, 1, 2, 3, 6. So it's 4, 7, 9, and 8. There as possibilities. So this sees 2. That's fine. This sees 7. That's fine. This sees 8. That's fine. This cannot be 1, 5, 8, or 9. So it could be 2, 3, 4, 6, 7. This can't be 6. This can't be 6. This can't be 6. Whereas the 6 in box 5? It has to be here. So this is 6, which means this can't be 6. This is 9. So none of these are 9, which means this can't be 4. We have a 1, 3, 4 triplet in row 2 and box 2. So the rest of the row 2 cannot contain a 1, 3, or 4. And the rest of the box cannot contain a 1, 3, or 4. So therefore this is a 6. This has to contain a 7 and a 1, 2, 3, or 4. Obviously 2 can't be there. This is 1, 3, or 4, so this can't be 4. So this is 7, 8, and 9. This can't be 9. This is 4, 5. Okay. So 7's one of these 2 cells. The 6 can only go here or here. Okay, this can't be 6. In addition, it must connect to one of the... It must connect to the other unshaded cells. So therefore, it has to be connected to a 1 either way. It cannot go up. It has to go to the side, which means the 1 has to be one of these 2 cells, which means this can't be a 1. Therefore, this is a 7. This can't be 7, so we have a 1, 6, 1, 6 pair now in row 7. So this can't be 1. This is 7, so it cannot go down here because then this would be connected to a... So therefore, this is shaded. This still could go up, which is fine. It could go to the left. That's fine also. What else are we doing here? This has to be what? 2, 3, 4, and 7. Obviously 2 can't be here. Oh, these has to be consecutive. So this can never be 1. 3 or 4 could go with 3, 4, 5, or 6. That's fine. This is 1, 2, 3, 4, or 7. Okay. So this sees 5 at least here. If it continues here, this would have to be a 3 or 4 to be consecutive here. Therefore, it cannot continue onto here then, because this would have to be 5 away from 3 or 4, but that's not possible, right? So again, we can't have 1 and 2 here, so this can't be 1, because the 2 is here. Therefore, this, even if it extends to here, that's only 6. So it has to extend at least these two. Therefore, this is low, and therefore this is high. Which means this has to be 1, 2, or 3. It cannot be 7. Therefore, this is a 7, because we have a 1, 2, 3, 4 triplet in box 5. Sorry, 1, 2, 3, 4 quadruple in box 5. We also know, so these are not, yeah, this is a boundary. This is now a boundary. We have a 1, 2, 3 triplet now in box 5. So therefore, the rest of the box cannot contain 1, 2, or 3. Therefore, this must be 4, which means this can't be 4. This is 2 or 3. This is 2 or 3, which makes that a 1. So these can't be 1. They have to be 3 or 4. This is 1, 2, or 3. It can only go to a high then, and the only high possible now is a 7. So this has to be 1 or 2. We don't know if that's connected. So this has to connect this way. It either connects one more here, in which case it'd be 1, 2, 1, 2. So these can't be 7. Or it connects here. In this case, it would be 3 or 4. So this is 7. This then has to be... So this can't be 1. This can't be 2. Therefore, this is 3, 4. We have a 3, 4, 3, 4 pair now in column 6. So the rest of the column cannot contain a 3 or a 4. Because we know 1 has to be one of these two to connect to the rest of the unshaded cells. So that can't be 1. And 2 is here, obviously. So this can't be 2. So it could connect this way, could connect this way. We're not sure which way. This could actually connect to here. So this could be unshaded. What else are we missing then? If this is unshaded, this would have to be a 7. And therefore, this would be 6 and shaded. If this is not shaded, this has to be unshaded. So it would have to be a 3 or 4 to be next to the 9. So you can never be 5. So this is either 6, 7, or it's 3 or 4. We're not sure which. If this is 7, this has to be 2. So then it would be 7, 6, this would be 2. If this is 3 or 4, this would have to be 3 or 4. So none of these could be 3 or 4. Therefore, the 4 would have to be here, and the 3 would have to be here. So this could not be 3, this could not be 4. And then this would be 3, I guess, because this would be 4, 3. This couldn't be 3, this couldn't be 3, this would have to be the 3. So one of these is 1, obviously. This could be 1, 3, 4, and 8 and 9. This can't be 3. So we don't know with this one. This one can only see 2, 3, or 4. But still could be all the 2, 3, or 4. This can't be 1. This can't be 1, 4, 1, 6, or 7. So it could be 2, 3, 4, 5, 8, or 9. But obviously that can't be 2. This can't be 4. So this is a 3, 5, 3, 5 pair. Therefore, this has to be 4. This can no longer be 4 here. Well, we already knew that because that was a 4. So we have a 3, 5, 3, 5 pair in row 6. We also have 4, 6, and 7. So therefore, 1, 2, 8, and 9 have to be in the rest of the row. This can't be 2, obviously, so that's fine. This can't be 8 or 9. Aha. Okay. This can't be 8 or 9 because of the 8, 9 pair in row 8. So the rest of the row cannot be 8 or 9. Where are the 8 and 9 then? We have a 1, 3, 4 triplet now in column 5. So the rest of the row cannot contain 1, 3, or 4. Therefore, this can't be 3 or 4. This can't be 1, 3, or 4. So therefore, it has to be 8 or 9 or 8 or 9. Therefore, this cannot connect this way. And we know this must connect to all the other unshaded cells. So it has to connect this way. So therefore, this is unshaded and connected this way. This is shaded. If this were to be shaded, it would have to be high, but it can't be high. Therefore, this has to be shaded. Sorry, if it were unshaded, it would have to be, yeah. This can't connect to here. So therefore, because it's not, doesn't have a difference of at least 5. So this is shaded. This has to be shaded again because it would only connect this way, but it's not 5 away from here. So therefore, this is shaded too. Therefore, one of these two is shaded. We're not sure which. This cannot be shaded because if this were shaded, it's next to a 4. Or sorry, can't be unshaded. I keep getting that mixed up. But it cannot be unshaded because it's next to a 4. And therefore, it would not be 5 away. Therefore, this is shaded. So we now know the boundaries of this. This has to go here to here. This can no longer be 1. This can no longer be 1. We have a 3, 6 pair now in column 3. So the rest of the column cannot contain a 3 or a 6. So this can't be 3 or 6. This can't be 3 or 6. In addition, you can't have 5, 8, and 9. So there's no 1, 2, 3. It could be 4, can't be 5, can't be 6, could be 7. So this is 4, 7. We have a 4, 7, 4, 7 pair then in column 3. So this can't be 7. This has to be 8 or 9. This can't be 4, 8, or 9 because we have an 8 or 9 pair also in column 3. So therefore, the 5 has to be here. So this can't be 5. This is 4, which makes this a 5. This can no longer be 4 or 5. This can't be 4. We have a 2, 3, 2, 3 pair now in row 7. So the rest of the row cannot be 2 or 3. Therefore, this is 8 or 9. The 5s can have to always be shaded. So therefore, this is shaded. We have to connect somehow to this one, and then we connect somehow to here. So the 4 could go here and be shaded. This could be shaded too. This could go 1, 7, and that would be fine. This cannot be, this could be 1, 2, no 3. It could be 4, 6, and 7. There's no 1 though, because we know the 1 is here. So if this were unshaded, it would have to be 6 or 7. This also, okay, so this could be 3, 4, or 8 and 9, right? This sees 2 or it sees 3, right? If it sees 2, it has to go this way, right? Because if it tries going here, it would have to also have something here, right? And if it tries going here, it would also connect here. So if it's 2, it specifically has to go there. This would be 3, then this would be 2. So that's possible. Hmm. If it goes this way, it would have to go 7, 2, and this would be 3. This would have to be 6. And it would go that way. So then it would have to connect here to have 3. So then this would be 8 or 9, 8 or 9. This would be 8 or 9. This would be 1 or 2. It could connect this way. What about if we tried going this way? Is that possible? Okay, if we tried going this way, this would have to be 8 or 9, but this would have to be 3 or 4. Because it's connected to 2 unique numbers, because it has to extend... I mean, I guess... Okay, so specifically if we're going this way, this would be 8 or 9. This would have to be 3, therefore that would be 2, but then it would connect that way, so that would see 3. So they cannot go all the way here and then connect this way. What about if it tried to go like this? Then this would also be 3, right? Right, because it'd have to connect this way. Can this ever be 2 is the question, right? If this is 2, it has to connect this way specifically, and then it goes up and down, right? Therefore, if this were 2, this would have to be 8 or 9. This would have to be a low, because it has to connect this way. But then this can't be 2, can't be 6 or 7, because those aren't low, so it would have to be 4. But then 4 would be consecutive with 2 unique digits with the German whisper rule. So that's not allowed. Therefore, we know this can't be 2 then, ever. So this has to be 3 all the time. So therefore, this can't be 3. This is 2, which makes this 3. Therefore, these two cannot be orthogonally connected unshaded cells. Therefore, this must be shaded, which means this must be unshaded, and it must be a low. Therefore, this has to be a 3. This is a 4. This then has to be 6, which makes that 7. This sees 3, so this cannot be 3. This is 4, 8, and 9. This is 8 or 9. We have a 4, 8, 9 triplet in row 9. Therefore, the rest of the row cannot contain a 4. Therefore, this is 3. This is 1. This is 4. So this is 3. This sees 1, 2, 3, 4, 5, 6, 7, 8 already. So this cannot be unshaded. So this is shaded then. This has to be the unshaded to connect, so this must be 1, which makes that 6. This can't be 1, this must be 3 now. This has to be 1 then by Sudoku. This must be 5 by Sudoku, which makes that a 6. This 3 means this can't be a 3, so this is a 5. This 9 means it can't be a 9, so therefore this is an 8. This is a 9, this is a 3. This can't be 3 anymore, therefore this is a 1. This can't be 1, therefore this is 2. Right. So the 3 has to see 3 cells. We're not sure which way. This cannot be 7 or 6, 7 or 4 anymore. So we have a 2, 6 pair. So it cannot go this way. So therefore this is shaded. Therefore, to connect these cells, these unshaded cells with the rest of the unshaded cells, it must go through here. So therefore, oops, this must be unshaded cell. So it connects this way. Therefore, we have to see 3. Therefore, this must be unshaded. So therefore, it connects that way. Therefore, this has to be an 8, 9. We now know we have an 8, 9, 8, 9 pair in row 6. The rest of the row cannot contain 8 or 9. It can't contain a 2. Therefore, this must be a 1. This is actually blocked then because this only sees 3. So this can't be 1 or 3 anyways. This can't be 1 or 3 because of this 3 here. This can't be 3 or 4. This becomes a 2, 7 pair. The 3 cannot be next to a 5, 6 with the German whisper rule. Therefore, this has to be shaded, which means the rest of this must be shaded because they can't connect orthogonally with the rest of the unshaded cells. Therefore, this must connect this way, which connects this way. So this is 8 or 9. So this is all unshaded. This has to be connecting this way. Therefore, this must be a 2 to connect to this. So this is a 2. And it can connect this way or this way. We're not sure which right now. Okay, so this is 2, which means this has to be 6. Now we just do Sudoku, I think. So this can't be 6. This is 5, which means this can't be 5. Therefore, this is 6. This can't be 5, so this must be 4. This can't be 4, so this must be 5. This can't be 4. So therefore, this is an 8, 9 pair in row 9. Therefore, this can't be 8 or 9. This must be a 4. So it cannot connect this way. So this must be shaded. So it must connect through here. And therefore, this has to be unshaded. So it has to be shaded also to not, because it can't be connected orthogonally with the unshaded cells. So that's all the shading now. That's all done. And now we just need to do Sudoku to basically solve the rest of the puzzle. So this is next to a 4. So this has to be a 9 then, which makes this an 8. This could be 8 or 9. This has to be 9 though because of this 8. So therefore this is 9, which makes that an 8, which makes that 9, which makes that 8. This can't be 3 anymore. This must be 4. This makes that 3. This can't be 9, so this must be 8. This can't be 8 or 9, so this is 7. This can't be 7 or 8, so this must be 9. This can't be 2, so this is 7, which makes that 2. This can't be 1 or 6, so this is 3. This can't be 3 or 6, so this is 1. And that's a solution. Pretty cool puzzle. I do like the shading because it's coloring, I guess. So I like coloring a lot. So this was actually pretty fun for me. And I hope you had a fun time watching me solve this. And I'll see you next time on Frank Puzzles. Take care.